Welcome to the second part of Matrix Algebra 101, part of the TLR animal breeding course. I just want to remind you that in part 1 we've looked at a few definitions and descriptions of what a matrix is, and also describing the elements of a matrix, the rank or order of a matrix, that's the size of a matrix, and the whole description. What we will be looking at in the second part would be some calculations done in matrix algebra. Like in conventional algebra, in matrix algebra we have the option of also using matrix algebra in certain calculations, such as addition, subtraction, and multiplication as examples. So we will then pursue on this, and we will show you how this is done with matrix algebra. We will then start off by explaining addition and subtraction of matrices. Now, two matrices can be added to each other or subtracted from each other, but this can only happen if they have exactly the same dimension. That is, it means that they must have the same number of rows and columns. So this is a simple process. The addition or subtraction is accomplished by adding or subtracting the correspondent elements. For example, if you have matrix A and matrix B, in order to add the two matrices together or subtract from each other, it doesn't matter whether the sequence of events. So A plus B equals B plus A. You will see later on when we discuss multiplication that might not be the case. But in terms of addition, it doesn't matter in what order you add the two matrices. So consider the next possibility. We have matrix A and matrix B, and you can see in terms of the order of this matrix, 2 rows, 3 columns, 2 rows, 3 columns. So they are exactly of the same order, so we can add the two matrices together. So a simple mathematics then, A plus B, matrix A plus matrix B, and you will see that we just simply add each of the elements. The element in position, two elements in position 1, 1 gets added, and so on. So basically that, and then the answer would be how we added each of these elements. So this is our result. Call it matrix C if you like. The same for subtraction. So matrix A minus matrix B. Each of the elements are simply subtracted from each other, and that will give us the new matrix, which is then the result of our subtraction. Next, I would like to discuss matrix multiplication, and the first one, that's a very simple thing to do, is how to multiply a matrix by a number. We would also call it a scalar. A number in matrix algebra, a simple number, a numerical value, will be called a scalar. So how do we multiply a matrix with a scalar? So if our matrix again is matrix A, and let's say it's a 2 by 2 matrix, and you can see the elements 100, 200 in the first row, 300 and 400 in the second row, and if we multiply matrix A by 5, the number 5 or the scalar 5, it's simply multiplying each of these elements with the scalar, in this case by 5. So you end up with the new matrix where you just multiply each of these elements. So a very simple process, multiplication of a matrix with a number. A more complex calculation would be when you multiply two matrices with each other. And here you must be very careful on how this happens and also the sequence of events. So the first rule is you can only multiply two matrices when the number of columns in the first matrix, in this case matrix A, is equal to the number of rows in matrix B. Listen carefully. You can only multiply two matrices when the number of columns in the first matrix equals the number of rows in the second matrix. So obviously that could mean that A times B in this case could not be or cannot always be the same, or isn't necessarily the same as BA. So the sequence of the multiplication is also very important. So if you then want to multiply B by A in that sequence, it also means that the number of columns in B needs to be equal to the number of rows in A. Okay, so suppose we have a matrix A. It's an I by J matrix. That is the number of rows and the number of columns. And B is a matrix of the size J by K. Then the matrix products A and B results in a new matrix C, which is I rows. Can you see that's the number of rows in column A, I by J, and K columns. That's the number of columns of matrix B. Each of these elements in this new matrix, this result of our calculation or multiplication, will be according to this formula. So it's basically a sum of the multiplication of each row of A element with each column of B and summed up together. This sounds a little bit maybe complicated, but I think as soon as we show you an example, you will see exactly what this means. So this is our example. We have two matrices. Matrix A. Matrix A is a 2 by 3, 2 rows, 3 columns, and matrix B is a 3 rows, 2 columns. We can multiply them because the number of rows in A equals the number of columns in B. So we can multiply the two matrices. So our first element that results from this multiplication would be summing up a lot of multiplication. So it's 0 times 6, 0, our very first element in A, times 6, our very first element in B, plus 1 times 8. So you move along this row of A. So it's the second element in the first row with the second element in the first column of B. We add that up, and then we multiply the third element in row 1 in matrix A, multiply that with the third element in column 1 of matrix B. So, and then you add all up and you end up, in this case, the answer is 28. So your very first element in the new matrix C would be then summing up of all these multiplications, 28. So that's your first step. The second step would then you start off by utilizing element 1, 2 in or to calculate element 1, 2 in matrix C. So we start off with, again, multiplication 0 times 7. So can you see we exhaust the first row first. So the first row multiplied by, or the first element in the first row multiplied by the second row's first element in your second matrix. So it's 0 times 7 plus 1 times 9 plus 2 times 11. And if we add them all up, we end up with 31. So that would be your first row, second column element. And then only we will go to the second row of your first matrix. 3 times 6 plus 4 times 8 plus 5 times 10. And that will then be in the second row, the first column, that element, 100. And then obviously the last calculation needed would be the second row of your first matrix and the second column of your first matrix. 3 times 7 plus 4 times 9 plus 5 times 11. And in this case, it will give you 112. So that's the way that multiplication of two matrices would work. So just the rule, you start off with the first row and the first column, then the first row, second column, second row, first column, second row, second column. Obviously, if you had 3 rows and 3 columns, you will simply continue in the same vein. So the order of multiplication, very important. Matrix multiplication is defined as AB, but that's not the same as BA or vice versa. Even if matrix multiplication is possible in both directions, there might be different results. So A times B is not always equal to B times A. So that's very important. So in matrix notations, certain jargon was developed to just describe this. So A is post multiplied by B. So B is the post or after multiplication. Or B is pre-multiplied by A. So A is pre-B. Or you can do it the other way around in a case of where B times A is described. So thank you for your attention. We have then looked at 2 or maybe 3 distinct ways of doing calculations with matrix algebra. The first being addition, the second subtraction, simple way. We also looked at multiplication, where you multiply a single number with the matrix, but also how you multiply 2 matrices together. We will then follow on Matrix Algebra 101 Part 3 later on.